Hi, Justus. Nice to meet you again.
Hi.
Great, thank you so much for taking a few minutes. Before we dive into all of our amazing questions, would you mind just starting with a brief introduction, maybe specifically touching on your current work with VOSS, but then also maybe the research work you did with the Technical University in Aachen?
Yeah, gladly. My name is Justus Benning, and I originally studied engineering and economics, so not quite AI because my focus was also mechanical engineering. But during my master's, I realized I really like this topic of digitalization and automation, and I also had a growing interest in AI. So I did a semester abroad in Korea, in at Korea University in Seoul, and there I went because there were actually quite a lot of subjects and modules to be taken for engineers that want to learn AI, which was a bit underrepresented at my university in Aachen. And after that, I applied for a master's thesis of towards the topic of creative artificial intelligence, which I think today would be coined generative artificial intelligence. But there, back then in 2018, there wasn't the hype around it. So me and my thesis supervisor, we called it creative AI. Which was basically AI doing creative stuff like writing texts or designing parts, music pieces, sound design, and so on. And based on that, at the same institute, I started as a scientist there, as a researcher, but also as a consultant. And I built up my own research group regarding AI because something like that wasn't at this institute before. I built it up and we developed consulting products, but also research projects towards artificial intelligence, mainly for the manufacturing sector, but not exclusively. After that, also during my PhD thesis, I knew that I wanted to go into the industry after my stint in academia. And so I started at VOSS Automotive, um, where I work now since 5 months, a bit more. And VOSS Automotive itself is an automotive supplier of mainly fluid connectors, fluid hoses, hydraulic systems, and so on. But they branched out into innovation projects. One of them is a smart product called ClickID, which is a glove that I have here also, which I can briefly show maybe. So this device here goes on your wrist and you can wear it as a glove. And there is multiple sensors in there, including acceleration sensors and microphones. And we use sensor fusion and, you guessed it, AI to in a manual assembly process, assess whether a connection has been made. So we look for a sound like a click of a connection, and then the glove can recognize it if it is trained on the specific sounds in that manufacturing process. Why would you want that? Well, in automotive, but also in other industries, there's still a lot of manual labor, especially in assembly processes at the end of the line, where you have lots of cables, three-dimensional workspaces where robots don't work as well. And we want to make sure and give the workers assistance in whether they have made a connection successfully. Because this is still quite error prone, because you may imagine that after 8 hours of assembling something, you start missing stuff. Maybe you lose a bit of focus or you have to make connections where you can't see them. So we also provide tactile feedback, and maybe you have different variants of products that you're assembling with a varying number of connections, when the glove also supports you in that, because the glove, if it's connected to the production IT system, knows how many connections you have to make. What my role is there is I am trying to improve the performance of the AI model and also the scalability of the AI solution in general, of this smart product.
Fascinating. Before we go through some of the questions that we might discuss afterwards, let's maybe talk a little bit about your research and consulting engagements at Aachen,
Yeah.
as far as you can talk about it. What were maybe the top two, three engagements that stood out to you the most?
I think what I would want to single out would be it was a research project. I don't, it was basically a government subsidy for us to do, we had to call it support, not consulting. But for SMEs that normally don't have the budget for maybe bigger consulting projects, they could without a lot of formality, without applying for grants and so on, approach us. And the research project would fund our consulting, and we could go into the SMEs who had the practical challenges. And this was always super interesting because they were like mini consulting projects, and we basically consulted on whether a use case should be solved with AI or not, because there's a lot of misconceptions there. And if it is solvable with AI, maybe what's the approach to do that? Maybe there are already ready-made solutions and suppliers that know about perfect AI solutions for your use case. Because that's also something that people, I don't think, realize a lot with AI. For small enterprises to employ AI, it has to be a product, it has to be a commodity, something that is already almost a ready-made solution, because they will not employ a data scientist for one use case or somebody who continually codes or checks the model. And we went in there, a lot of the use cases were predictive quality, process automation and so on. We consulted on whether they can do it, and it was a lot of fun because I got to know over the course of 2 years, I think 30 different SMEs in Germany. They were always really grateful and happy about their advice.
It's definitely a, I guess, challenge that I face pretty much every day. Is this a problem where we should use advanced forms of AI, maybe in some cases even Gen AI to solve a given problem?
Yes.
What were some of the, I guess, verification questions that you either went through yourself or discussed with your stakeholders to understand what type of solution might be right for them?
Yeah. So I kind of implicitly learned it on the job, what should be done with AI and what shouldn't. But recently I read a great book by Andrew Burkhoff called Machine Learning Engineering. So not data science, but the engineering part of machine learning. So how do you really apply it? And he has summarized it very great. If you have a step or a process or something that should be automated, but it's almost impossible to code with rules, and you don't care that much if it's 100% correct, so maybe 90% accuracy is enough, and you want it to be deployable fast and anywhere. Those are like 3 very strong hints that you should use AI. If it's something that can be covered with rules, like hard-coded, use rules. They're more reliable, you know. And if you need 100% accuracy, maybe you need a person doing it or 2 people doing it with like looking at it. AI will never have 100% guaranteed reliability. And if you can afford to put a lot of work into coding these rules and you don't have to deploy it everywhere, maybe you should do that. But if it needs to be kind of a fast and precise enough solution, that's always a strong hint that you can use machine learning.
You already mentioned that you've worked with around 30 SMEs in Germany, and Germany is, I guess, globally quite popular for some of the hidden champions. So really specialized SMEs that develop a strong, very solid, defendable market position.
Yes.
And you alluded to some of the possible misconceptions, maybe I'm putting words in your mouth here, regarding AI, amongst some of the amongst some of the SMEs. But what were some of the challenges that you've seen sort of across these 30 organizations as it relates to implementing AI use cases?
Mm. Yeah, you're not putting words in my mouth. There are definitely misconceptions about AI, especially in those enterprises, but I want to make the clear distinction. I don't think that's bad, and I don't think it's their job to know everything about AI.
Mm,
Because, like I said, AI, for them to be employable, has to go through this commodification. It needs to be a product. So
mm,
you also wouldn't expect an SME to code their ERP system themselves. I mean, some of them do that, fair enough, but most of them, they buy something, maybe SAP or something that's more tailored towards SMEs, because it's not their job to know how you code an ERP system. It's also not their job to know how to code AI or the specifics of AI. Their job is, like you said, to have a great product, to manufacture it in German quality, and to distribute it around the world. So with that very understandable distinction of skill sets come very characteristic challenges, which is either when you first approach or when they first approach you, either a too positive or too negative expectation of AI. So too positive is mostly very interested people in managerial positions who read a lot of blog posts and a lot of the hype around AI. And they ask you, okay, we have this huge business problem. Can't we use AI for it? And they expect a complex problem that is also comprised of multiple sub-problems to somehow be solved with the AI. And then you have to explain them that AI is actually much less intelligent than you are led to believe in the beginning when you first read exciting headlines. And the too negative is mostly people who have either already made bad experiences, unfavorable experiences with AI, or who read those headlines and don't trust them, rightfully so.
Mm. More generally, sort of zooming out from the SMEs you've worked with and
Mm,
looking, now you work for a large automotive supplier, and you also have really good visibility of some of the, I guess, ins and outs of AI conversations amongst OEMs.
mhm,
Sort of generally, do you feel like the topic of especially talking about Gen AI
mhm.
is there seems to be so much hype around it, especially if we look into some of the consulting reports, some of these
Yeah,
conference presentations, all of these big promises of trillions of dollars globally in terms of possible savings. And then reality today is sort of a fairly low rate of POCs that actually scale, which are sort of the really, in just from my limited experience, these sort of really obvious use cases, low-hanging fruits that we would have expected. And
yeah.
there are quite a lot of scenarios in between. What would be your perspective on, is sort of Gen AI currently overhyped, and what might be sort of on a high level, a possible trajectory for the topic amongst automotive companies?
I think my answer has parallels to my previous answer. So is it overhyped right now? In my opinion, yes. Is that a bad thing? Not necessarily. I think it's just something that happens in the society and in the economy that we build right now. So there is I mean, it's the Gartner hype cycle. There's even a name for it. You know, it's so popular. It happened so often to technology that Gartner sat down and was like, wait, this always happens. Can we describe it? So right now, of course, we are building towards the peak of expectation. And then, of course, in the near future, there will come like a sort of a plummet. It's dependent on the technology, how deep that plummet is. Um, and then we get into this plateau of productivity. But yes, objectively, scientifically, you can say it's too overhyped, because with I feel like with every AI technology, a few years ago it was computer vision. You have this this big view of maybe it could solve everything that's wrong, and then only through trial and error you will find out those use cases that will actually bring you value. And I think Gen AI is extremely important for manufacturing industry. I think it is a very, very cool step scientifically, but also economically. And it will find long-term adaptation, and it will definitely save money in the long term, but not as immediate and as easy as people want to believe right now.
Mm. When we briefly spoke a few weeks ago, you mentioned that it could be a point of diminishing returns and, I guess, a limited set of use cases
Yeah.
where we can apply some of these large language models. Would you mind just expanding on that and why it matters in the context of this conversation?
So diminishing returns, I think, is there from the standpoint of model capacity and model capability. I don't think with AI there's a lot of diminishing returns where you can find use cases. You just have to be creative. And I will guarantee you, we will keep finding super cool stuff for Gen AI that nobody thought about before. Right now, I think the big thing is, I mean, the standard use case, you said low-hanging fruit, is retrieval augmented generation, which is basically take the knowledge of your enterprise and make it accessible through this easy assistant interface, which is super cool. But I think the options are quite limitless there. You just have to work hard to find them. These diminishing returns are very important for me to stress, because especially with AI, people are bad at extrapolating. So what will this be in the future? Because people either think that progress comes kind of linearly in a linear fashion, and they think, okay, we are here now with Gen AI, so in 3 years we must be double as good. Or they even think about it exponentially with AI, like moving towards this singularity, very sort of philosophical topic. Will AI at some point accelerate itself? The truth is, AI is not AI is just a field of research. You know, AI is artificial intelligence comprising multiple subfields of research, and in research, what you have is not linear and not exponential. What you have is kind of following the laws of evolution with these jumps. So you have a plateau of research, nothing much happens, people are trying out a lot of new things. 99% of those things never merit anything economically, and then you kind of have this jump where you solved another problem. We observed this 10 years ago with computer vision. You know, computer vision 2010 was nowhere near where it was today. And then somebody thought of convolutional neural networks. And we had this jump, and suddenly computers could recognize images. And once that problem was solved, nothing much happened with it. I mean, we got a bit more out of it. Now we can filter out videos, and the image recognition got faster and more precise, but nothing much happened. And then we had this jump, this very concentrated jump in productivity again. If you set the timeline from the first paper talking about transformers, the technology that made Gen AI possible on the scale that it is right now is 2017. And towards, I think, the first big publication of ChatGPT as a web service, which was in 2021, I think, very early, at least for Europe. And this was this Cambrian explosion. And now we're kind of riding the wave, but it will slow down again, because you can't just make the models bigger. It worked in the beginning, but right now the resources to train a model that is perceivably better than GPT-4 are insane. GPT-4 is enough. When I'm talking to GPT-4, I have the Pro account. I don't wish for a better language model. It can code, it can talk, it can format, it can recognize images. I don't need much more out of that. So those are those diminishing returns that I was talking about.
Yeah, building on some of these last points, there seem to be a lot of questions and conversations around smaller language models that can run on various types of devices. Do you think this is a trend that will continue? And if so, what is your perspective on challenges and opportunities associated with it, and maybe certain types of use cases?
So I think that's a very interesting question, because we are definitely at diminishing returns when it comes to the big language models and their performance. There are even papers scientifically showing that just increasing model size and training data size will not yield a better zero-shot performance. So a model that is somehow more intelligent for tasks it has never seen will not work. At least the maths they don't add up. But this other direction always happens. We can again look back into the past 10 years ago with convolutional neural networks for computer vision. Back then, these things were huge, and they took days to train, and they ran on very powerful machines. Right now, on your phone, you likely have something called MobileNet V3. It is tiny. It is a model that is, I think, in the few megabytes. It has an insane inference speed, even on a tiny CPU, because people worked for years. How do we compact this model, this information, even smaller? And this is the model that, for example, if you have an iPhone, can recognize your friends on photos or your pet, and it makes you like a kind of a highlight reel of your pet in February or something like this. So you can see like it provably runs on the edge. And for language models, there are already developments into that direction, which are very, very interesting, because really think about the implication of not having to access the web, or only very sparsely having to access the web, and having a full language model run on your phone. I think this is amazing what you could do with it. It would essentially be a Siri that's 10 times smarter. You could maybe kind of dictate something into your phone very roughly, and then at the end say, please make a well-formatted Word document out of this. And it would do everything that a cloud model right now can do. And for that, a lot of things need to happen. One of the cool things, I think, as an example, so it gets more tangible, that I can say, how can you make a model smaller? People realized essentially a model is just a big matrix, just tons of parameters. And you have an input vector, which are your words, they go in, and then there's some matrix multiplication happening. And through a lot of analysis and linear algebra, in the out of the end comes the next word that makes sense. And people realize that these weights that are stored in the model right now, if you're working with computers, normally you have like 32-bit integers, which are very precise, long floating point numbers. So every one of those weights was super precise. People realized you can just cut those numbers. You don't need, for the model to work, you don't need all those decimal places after the comma. The 20th decimal place doesn't do anything with the output. So you get what you can call quantized models. So you do a quantization, reducing the 32-bit floating point values down to 8-bit and sometimes even 4-bit. And they made experiments when the model starts degrading in performance. And if you go lower than 4 bits, the model starts hallucinating and doesn't know anymore what language is. But you can essentially, without losing almost any precision, just cut away 3/4 of your model, just like that. It's free performance gain.
It's fascinating and seems to be, sort of from my naive outside perspective on the subject, quite relevant as it relates to lots of the possible use cases in automotive. So thinking about in-vehicle experience, or anything that's associated with sort of in and around the vehicle. And then
Absolutely.
also, I guess, the engagement with lots of companies offer sort of one app where they manage the end customer relationship, where this could be sort of very, very suitable. Would you agree with that? And what might be some of the use cases in the space that are particularly relevant to automotive OEMs or suppliers?
Yeah, I think it would just make a lot of the features that we are starting to have, that are starting to be good, even better, and make it feel more natural and more refined. So we have CarPlay right now, but at least my personal experience with CarPlay, be it Android or iPhone, is still like asking 2 times, like, can I navigate here or play this song? And then it doesn't understand. And sometimes it works, sometimes it doesn't. And it can definitely help to have just a very, very seamless experience there. Just tell your car, hey, comprise a pop playlist of 25 songs, play it in the background while you navigate me to XYZ. So having very complex commands, essentially talking with your car like an intelligent listener. So absolutely, we can have it there. And like you said, it extends, I think, out of the pure car experience towards smart assistants, handling customer relations, and so on. Yeah, I think we will definitely see an improvement of features that people are trying to perfect since at least a decade.
Mm. Lots of the use cases that we currently think of rely on quite specialized training and training data. And especially when I talk to executives that haven't really worked in the domain, I think they have some misconceptions around how difficult and what some of the challenges are as it relates to this very sort of use case domain specific training. Just from your
Absolutely.
experience, what are some of the, I guess, the really tough challenges as it relates to improving the model in a direction for very, very specialized use case?
Yeah. So with this very broad applicability of these Gen AI models, we kind of also shot ourselves in the foot. Why? Because they are so good and so flexible, and they understand us so well because they are trained on unbelievable amounts of data. Like, I could tell you what the size of the data is, but your mind cannot imagine it. You know, like when you think about the size of the universe, like maybe you get an inkling, but it's terabytes of text data. Basically, they downloaded the whole internet. Which also means that once this model has, through the training process, distilled the knowledge in the data into itself, it's such a highly complex system that, unlike other machine learning models that can maybe learn quite quickly, you will not be able to reproduce this process, and you will not be able to significantly alter the model. It is, you're standing in front of it like a very much like the much quoted black box in AI. There are some techniques to fine tune already existing models. RAG technically isn't fine tuning. You're just using the model to intelligently look up stuff in a database, but you can improve the model. There's something called LoRa or QLoRa, which is low rank adaptation, which is carefully tuning some of the weights, but this handles more style transfer than making a model more intelligent. So especially Gen AI has exactly this problem that you're talking about. It is very difficult to get a model that is working on a product like level of maturity for special use cases. Because as a rule of thumb, if you think that there isn't a description or a conversation in the internet happening multiple times about the use case that you're trying to solve, the model will not be reliable because it's trained on the internet.
Related to the topic of data, I hear quite a lot of conversation related to synthetic data. Maybe first of all, do you use synthetic data for your
I
current
love
work?
synthetic data. Everybody does. Every data scientist does. Yeah.
Why is that the case, and where do you use it?
Synthetic data is cheap. So what is synthetic data? I mean, yeah, you could also use it in the context of Gen AI, but I think a more visual example, at least for right now, is in computer vision. And sometimes computer vision models can be generative. So, you know, DALL-E generating pictures and so on. So let's roll with that for now. What is synthetic data? If I wanted an AI to a model to distinguish between cats and dogs, I feed it pictures of cats and dogs. Everybody knows that example. And the photos that I myself took or downloaded from the internet, they are my original training data set. They are real photos of cats and dogs. What I try to do with synthetic data is synthesize data from the original data that somehow augments my training data set. That's why you also talk about data augmentation. So what you can do in this visual example, why did I pick it? If you just want a model to recognize cats and dogs and you have a picture of a cat, you can flip the picture of the cat. For us as humans, we still recognize it as a cat. And you can teach the model to be invariant to this flip or to this rotation. And you can stretch the cat maybe a bit. It's still a cat. As long as the human mind is going to be like, that's probably a cat, you can augment this original photo 20 different times, yielding you original data set of size 1 and maybe a synthetic data set of size 20. You mesh those together and you get two results, hopefully both, sometimes neither, as always in AI. You once get a model that does perform better because it saw more data, and in AI, data is everything right now. And you have a model that generalizes better, so it's more robust. So when it sees a new, completely unseen example, it is more likely to just classify it correctly. And this data augmentation and creation of synthetic data you can do for any kind of data. There are model-based approaches that really do not care what kind of data it is, sound, image, and so on. It just looks at a vector in an abstract space and tries to create more vectors around it that make sense. Or you take this very reality-informed approach of when I flip a picture of a cat, I can still see that it's a cat. I sadly have to work with sound data and acceleration data, and this is a horrible kind of in-between thing. So what I try to do, if my glove is trained on a specific sound, maybe I carefully add some noise in the background, or maybe I stretch the signal a bit, or maybe I pitch it down just a tiny bit. But this, you have to be much more careful there than with image data. Two things. Synthetic data is cheap and it can definitely improve models, but always be aware it's never as good as original data. So you should only use it when you have already an sufficiently large or just almost sufficiently large original data set. You're not gonna create data out of thin air that solves your problem.
OEMs historically have been, and some might argue are still, for the most part, in terms of their bread and butter business, supply chain orchestrators.
Mhm.
And as it relates to Gen AI, all of them, as far as I'm aware, are still trying to understand what level of capability and type of capability they want to develop internally. So where they see a possible differentiating proposition for their products that has a advanced AI slash Gen AI capability. I was just wondering, sort of from your perspective, having worked in research, in consultative roles, and now you work with a supplier, to what degree do you think this innovation, especially in Gen AI, will come from, I guess, the supplier side, as opposed to the OEM side? And then what will be your recommendation for to OEMs in terms of making some of these decisions? Because everyone is trying to sell sort of additional solutions at the moment that have some form of Gen AI capability, and it's a little bit of a mess. So maybe there are some recommendations you could share in terms of how to navigate this currently very convoluted landscape.
Wow, that's a really good question. So it kind of points towards that normally with products, you kind of have this pull from OEM side. We want X and the supply chain has to deliver, correct?
Yeah,
And now you see this ecosystem of solution rolling towards the OEM with Gen AI.
yeah,
It's a really good question. I For me, in my personal feeling, I told you before we did this, I'm not like Gen AI, it's not my biggest focus. So I really think more about mathematical models and so on. But for me personally, the problem that Gen AI has mainly solved is that finally computers and humans understand each other. Before, if you wanted to really talk to a computer, to really make it do what you want to do, you either had to buy a software of a smart person who already programmed it, or you had to learn how to program. Programming languages, while getting more and more human readable, if you go from assembly to C to Python, they are still the language of the computer. You have to learn them over multiple years to become really good. Now you can just talk to a computer and you can say, generate me this image. You have integrated solutions in Adobe Photoshop saying, cut out the grass background, make me stand in a desert. You don't have to use the tools that the computer kind of forces on you anymore. You can use your human communication skills. I don't know if suppliers can, because that's for me the essence of Gen AI, what it really solved. Do suppliers really provide solutions where the initial problem was that humans and computers historically don't get along really well? Because the only thing that I can really think about is the example that you already mentioned, which is the user car interface experience. How do I talk with my car? How does my car talk back to me? Um, Everything else from supplier side, for me, is still very much mechanical engineering, haptic feedback, and design. So I would actually be surprised if suppliers come up with a Gen AI solution that sticks. Because right now I don't see it, which could be my limited creativity. But maybe you have a poignant example of something already being pushed or onto OEMs. But I think from the product side, it is more difficult than people realize.
No, really appreciate the perspective. Sort of building on it as a last final question.
Okay.
Imagine that you're talking to the chief data and AI officer at one of the incumbent automotive OEMs, assuming
Yeah.
that the role exists, which seems to be sort of the general trajectory at the moment. What would be your top 3 ±1 recommendations to him or her to unlock the most value in a sustainable way from AI in their respective organizations?
I'm it's also a good question because I don't know if such a role, if it is implemented, at least in the manufacturing world, will stick for very long, which is correlated to the very natural and just objectively observable hype cycle right now. Why do I say this? This is just a preface. I will get to a concrete answer, but you could really observe like around 2014 to 2017, when the big word wasn't Gen AI and AI, but the big word was digitalization, at least in the manufacturing sector. And also maybe 2018 and 19 when I started consulting. You just had to say digitalization and companies were interested.
Quiet.
Yeah. And there were these roles, I don't know if you remember, of CDO, Chief Digitalization Officer. And you could really see that they popped up. They employed very, very capable people in there with a great track record on the C-level. And these roles quietly, largely were removed then again. The people stayed in the company, but they went into a different department or they fulfilled the same role in a different way. But the CDO was never really replaced. So this was kind of a role that was there with a definite half-life, so 2 to 3 years. I will base my recommendations off of that. It's true that you have a hype right now. You are Chief AI Officer. The task of the C-level is to get people moving. AI projects work. AI projects are difficult. They are messy. AI is more than any other technology, something full of try and error by definition. So get people going, make them excited about AI, and motivate them. I think that's the best you can do. I don't think you have to really or really come up with the best technical solution for your company. You should hire great data scientists for that and great, I would say, AI product managers, whatever that means, but people from the business side who know what they want from an AI solution. And you have to kind of be a figurehead of AI, and you kind of have to do the marketing within your own company and maybe also a bit outside, and really carefully write the line between motivating people and over-promising what you can actually do with AI, and also not being too much of a stickler and being like, yeah, maybe this works, maybe this doesn't work. Because like digitalization, some of the projects that you will start will actually have merit for your company, and you will only see them to fruition if people are motivated and believe in your cause. There are great success stories of, when I think of digitalization, I always think about subscription business in manufacturing. There are success stories of that. There are companies who went from selling a product to selling a service, and they are much more scalable because of that. But you only get there when you really do the marketing, and be fully aware that after 2 or 3 years, maybe your role will change because you came from this initial C-level position, providing the guiding star, towards now you have 3 projects that are actually worth the time and the money, and then you operationally lead them. So yeah, that would be my advice and my prognosis of what will happen to those positions.
Thank you so much, Justus. Really appreciate your time and yeah, sharing your perspectives today.
No problem. Great pleasure to be here.